greatest common factor. It's called our GCF. It's the largest amount that you can pull out of every term. So problem number 1 here, we have x squared plus x. I notice that I have 2 x's here, right? That's x squared. Plus I have 1x here. So at most, I can pull out 1x out of both of those terms. So when I factor out one of those x's, both terms, I can write it like this. And if you wanted to, you could say that's the same as dividing by them. And if I divide by like bases, we subtract the powers, and it's always top minus bottom. So I have 2 minus 1, right? That power here is 1. So 2 minus 1 is 1. So that means there's 1x left behind. Another way to look at it is say that I'm going to take this x and I'm going to pull it out of here, and it still leaves me with an x. This is a positive divided by a positive. X goes into itself 1 times, so it's a plus 1. So my greatest common factor here is x. And when I've done factoring it out, this is my factored form. This is my answer. So now let's look at number 2. Number 2, we have 5x cubed minus 15x squared. Well, the first thing I see that they have in common is the 5, right? Because 5 goes into 5 1 time, 5 goes into 15. So at most, this is all I can pull out, because I cannot take 15 out of 5. But I can take 5 out of 15. So I know that that is part of my GCF. Let's look at it a little bit more. I see that I have 3 x's and I have 2 x's here. So they both have an x term, so we're good. So that is also part of the GCF, but how many x's? Well, there's 3 here and 2 here, so at most I can pull out 2 x's. So when I pull out 2 x's, that's the same as saying let's divide by 5x squared. And when I do that, I get these parentheses. 5 goes into 5 1 time. If I take this 2x squared and divide it into that x cubed, again, it's top minus bottom power. 3 minus 2 leaves me with an x. And then I got this positive 5 divided by negative 15. Well, 5 goes into negative 15 3 times, and it's a negative 3. I'm dividing 2x squared into 2x squared, and that leaves with 1 times 3, and that would be my answer. So my GCF here is 5x squared, and my whole entire factor form is 5x squared times x minus 3. So that is my answer. Let's look at number 3. Number 3 has a little bit more going on. We have 2 variables and the coefficients. I see that there's a 3 here and there's a negative 6. So at most I can pull out a 3. So we're going to say 3. But is that all that's going to factor out? Well, I have an x squared here and I have an x to the first here. So that means at most I can pull 1x out. What about my y's? I have y squared here and a y squared here. So at most y squared. So let's pull it out. I'm going to do that again. It's the same as dividing by it. And once I do that, 3 goes into 3 1 time. X goes into x squared, leaves me with x. Squared goes into y squared, leaves me with 1 times x. Minus 3 goes into negative 6, leaves me with a negative 2. X goes into x 1 time. Y squared goes into y squared 1 time. We got 1 times negative 2, so that is my end answer. My GCF is 3xy squared, and my factored form is 3xy squared times x minus 2. So now we're going to talk about something just a little bit different. So I need to erase this to give myself more room. And we're going to talk about factoring by grouping. So this kind of got us built up to the part where we're going to factor, recognizing what you can pull out. Sometimes your GCF is a 1. It could be a positive 1 or a negative 1, but sometimes that's all you got to pull out. In here, I see that I have 1, 2, 3, 4 terms. And if there's 4 terms, and adding and subtracting is going on around them, then that means we can do this by factoring by grouping. So we're going to go 1, 2, and right in front of this plus sign, I'm going to split it in half. I'm going to focus on factoring this part and focus on factoring that part. So just looking at these two, my GCF here, I notice is a Y because they both have Y's. They do not both have X and they're both not divisible by 5. So my GCF is Y. Same as dividing. So Y goes into Y once, leaves me with X times that 1. Y goes into Y once, leaves 1 times positive 5. So I factored this side over here. So let's look at this other side. This other side, whatever the sign is, if it's a negative or a positive, whatever it may be, bring it down every time. If you have to, write it in another color, highlight it, whatever you need to do, bring that sign down. That means I'm going to divide these two by this plus or negative, whichever one it is. So be careful and make sure you pull the correct sign down. And now look at it, I got 3y plus 15. So there's only one y. They both don't have y, so we know y. We can rule that one out. It's not a GCF. But this has a 3, and that's divisible by 3. So I know my GCF is more than 1 here. It is actually 3. That's the same as dividing by 3. 3 goes into 3 one time, leaves me with y. 1 times y is y. 3 goes into positive 15 5 times. So now I'm just going to rewrite this and clean it up just a little bit better so you can see what I'm working with. I have 2 terms here. This term has a monomial times a binomial plus a monomial times a binomial. This plus separates them, so there's 2 terms. So I'm looking at it. I am not done. My question is, what is my GCF here? Well, we need to look at it a little bit better. If we factored out the y up there and we left with x plus 5, and we factor it out over here and we got y plus 5, if you notice, whatever the parentheses is should look alike. If they don't look alike, well then we cannot factor this down. This is x plus y, y plus 5, so therefore we can't factor no further. But what if? What if we go back and we change this and it was an x here instead of a y here? I'm changing this, guys, so make sure you put this in your notes. If I need to, I'll change the color. What if this was actually an x here? So make a note before I change this to an x, and you can't change your equations. I'm just trying to show you 2 ways of answering this. So the other way, we would have said it would not factor, right? Or we would rearrange the 2 middle terms to try to see if it would factor, and we would realize it didn't factor. But in this case here, I said, what if that was an x instead of a y? Then we're going to say that we do have a GCF of what's in the parentheses. So that's the same as dividing both sides by the parentheses. And then that parentheses goes into that parentheses 1 time, leaves me with y. That parentheses goes in that parentheses 1 time, leaves me with the plus 3. And this would be my factored form. That would be my end answer. Just know that what we had originally would not have factored. It does happen every now and then. It's just not something that happens all the time. And again, I would have switched these 2 before I ruled it out to see if switching them would have gave me a different variable in there and that it became identical. Sometimes it works.